off by highlighting the 4 titles here. Our 4 titles are given, none, even root, and x in the denominator. Any struggles in the last 2 days, today can be a brand new day if we take good notes on this map. When something is given, what does that mean? Just not a trick question. You have it. You have it. So that's what this means by given. So for example, if I wrote down, so let's write the y first. For functions that normally don't have a restriction, I can be given one. For functions that normally don't have a restriction, I can be given one. For functions that normally don't have a restriction, I can be given one. So as people finish writing up that sentence, can those of us who did write already here, what's a kind of function that does not have a restriction? We've talked about 3 in the last 2 days. True, but what has that? What has all real numbers as a domain, always? Linear. Oh, hold on, I just need one example, linear. Give me an example of a linear function, any linear function you want. True, give me an actual, fill in the m and the b. 2x plus 5, great, f of x equals 2x plus 5. On its own, would this have a restriction? No, but I could give it one. Give me a restriction on x. What do you want to say about x? X has to be what? Greater than or less than? Let's say greater than or equal to 6. This is given. Given. It didn't start off, right, as a linear function on its own. It would be all real numbers, but we just gave it one. So if I box this, maybe you want to take out a pen. So you see how I put this in red? Maybe take a pen and do what I put in red in pen so it stands out. The more engaging your notes, the more likely you are to use them, okay? Let's talk about none. There's, like I mentioned just a minute ago, there are 3 that have no restriction. Who's got the first one? Linear. So hold on, let's put the general forms. So f of x equals mx plus b. Anything that looks like mx plus b, no restrictions. And what do these graphs look like for linear functions? Yeah, it can only either be a decreasing line or an increasing line. What's the second that has none? Quadratic. Very good. Quadratic functions. Quadratics. What's the general form for that again? F of x equals x squared plus b plus x. Good. And what do the shapes of these graphs look like? Think back to the end of last year. What do these look like? U's. And a U can either open up or down. U's that either open up or down. And there was one more that does not have a restriction. Odd roots. Very good. Odd roots. I have extra copies, so if anybody wants to, if anybody's made a mistake, you want another copy, let me know. Odd roots. And by odd root, we literally mean, like, give me an example of an odd root. Yeah, a cubic root would be odd. Any odd number here, 3rd root, 5th root, 7th root. That sketch is not as familiar to us, but for the purpose of our diagram, It's like a straight line that's got a bend in it that either starts up and goes down or starts down and goes up. And again, as I change color of my pens here, maybe you change between highlighting certain things, using your pencil, and then using your pen to create that same effect in your notes. If all of this is in pencil, nothing is going to stand out. So choose what could you highlight, maybe what could you write in pen, your choice. Now, why do all three of these fall under the same none category? Yes, all of them are all real numbers. No matter which graph you look at here, I have 6 possibilities, but no matter what, when I come in from the left, what do I hit? Negative infinity, negative infinity, negative infinity, negative infinity, here, negative infinity, negative infinity. And then for all 6 of these graphs, if I come in from the right, what do I still hit? Infinity. So for all of these, all real numbers. And in terms of the why, our graphs kind of back that up. So the strategy that we'll look at when we go over your homework, if you can identify these first, do these require any work whatsoever? No. Yes, I definitely appreciate, in terms of supporting why it's all real numbers, if you can name it. If it's linear, tell me it's linear. If it's quadratic, tell me it's quadratic. But other than naming it, correct. Absolutely no work needed, because the reasoning behind it, these are what their graphs look like. Okay, let's really get our listening ears on, because this box is going to summarize everything we did 2 days ago, and this box is going to summarize everything we did yesterday. Even root. What's an example of an even root? A square root. Good. Why is there a restriction on even roots? What's that reasoning why? Because you cannot do what? Cannot take, let's generalize square root to even root of what kind of numbers? Because we cannot take even roots of negative numbers. Can't happen. So if it can't be negative, that means what's underneath radical is what we call that sign, has to be, what could it be equal to? 0 or bigger. If something can't be negative, that means it's 0. We can take the square root of 0, because 0 times 0 is 0. 0 or bigger. So now let's talk how. So if you've been writing in pencil, I'm about to switch to blue, because I want what I'm about to write to stand out. So maybe you let this be in pencil, and now you switch over to a pen for the how. The how. What do we pay attention to? What do we highlight all day? What was that? Wednesday. Highlight what's underneath, or what's under the root. And the root only, right? Don't pay attention to anything out front. Don't pay attention to anything being added or subtracted. What was the next thing we did? Is it equal to 0? What's that inequality? Okay, so let's write a little more then. Set what's under. We used an inequality here. What inequality represents 0 or bigger? Greater or less? Greater than or equal to 0, and solve. Once you get your solution, your domain will be all real numbers, x greater than or equal to whatever you get. So after you do this math, that directly becomes your answer. So strategy to what to pay attention to. Highlight what's underneath the radical. Set what's under what you highlighted greater than or equal to 0 and solve. Our domain will be all real numbers, x greater than or equal to that. Keep in mind, when does the inequality sign change directions? When you divide by negative. So if you can, fit that on the side or on the back. Inequality sign flips. If you multiply or divide by a negative. That's the only time that this inequality will change directions. So what we just wrote, I know we wrote a lot in that box. Well, inequality sign flips if multiply or divide by a negative. So however you choose to write that. I know we just fit a lot in this box, but we just summarized an hour's worth of notes in one box. Yep, very direct. This is why and this is how. So for anybody who struggled on last night's homework, have last night's homework out, look at the back, because that's what this applies to, okay? So put the homework on the back, so it's right next to the box. Why do we have a restriction when x is in the denominator? Let's all sit up nice and tall. What can we discovered yesterday, what can we not do? What can we not do? Cannot divide by 0. Cannot divide by 0. That simple. We can't divide by 0. So we need to figure out what value or values, so we'll put an S next to it, on Fahad's desk are the organizers. We need to figure out what value or values of x make the denominator equal 0, and then what do we do with those values? Started with an E. There's that word we used when something is left out of the group. What's that called? X what? Exclude them. Yeah, exterminate. That was funny. I remember that from yesterday. Exclude them. So here's the reasoning. We cannot divide by 0. We've known that for a long time. So what we need to do is figure out what values of x make the denominator equal 0 and exclude them. So what did we highlight? Let's go through strategy now. I'm switching over to blue. Okay? Strategy. Highlight what? Highlight denominator. Two. What do we do with it? Set denom equal to 0 and solve. My domain will be all real numbers, X what? Not equal to whatever you got. The domain will be all real numbers X not equal to what you got. So now, right now, everybody who had a little challenge on the homework, go follow those steps right now on the homework. Look at the back. For anything that had a denominator, I saw a lot of people identify that the denominator was important, but you didn't know what to do next. So take a look right now, and I want you to have a moment of success on this. If you got the homework done, did you already check it with somebody else? Okay. So the couple of people who got that partial credit for the homework, you're going to try the homework right now. Everybody who did their homework and checked in with someone on it, you are going to start the independent practice. So raise your hand if you're ready for the practice. It's actually the inside page. Remember the mixed practice I told us we decided to told you not to do yesterday? That's what we're going to work on right now. Mixed practice. Did you check your answers with someone? You're not allowed to start the mixed practice until you start the homework with someone else. Those of you who are doing the homework right now, I want you to have success. Check in with me. Right? So keep working on it and then check in with someone. Yes. Yep. So what are we thinking on this? First, start by figuring out which ones don't have a restriction. So now that we're starting the next practice, this will finalize the video for today's notes. At any point, if anybody wants to go update their graphic organizer, this will be online by 3 o'clock. Good job today.